if the diagonals of parallelogram are equal, then show that it is a rectangle. Okay, so to show the parallelogram as a rectangle, you have to prove that every angle of the quadrilateral is equal to 90 degrees. So let us say this ABC is the quadrilateral. Then you have to prove that angle A equal to angle B equal to angle C equal to angle D equal to 90 degrees. Here, but here ABC is a parallelogram. We need to prove the rectangle. You have to prove angle A equal to angle B equal to angle C equal to angle D equal to 90 degrees. First of all of you draw the ABCD parallelogram. In parallelogram, already you know that opposite sides are equal, and you draw the diagonals also. Diagonals. Write down your given ABCD is a parallelogram. ABCD is a parallelogram, and diagonals, this is a B, C, D. In parallelogram, diagonals are equal. Diagonals AC equal to BD. In parallelogram, diagonals AC equal to BD. So what we need to prove? What we need to prove? To prove ABCD is a rectangle. Okay. So you prove Charlie. So you have to prove your ABCD is a rectangle. Rectangle means in rectangle each angle value is equal to 90 degrees. So that is we need to prove your angle A equal to angle B equal to angle C equal to angle D equal to 90 degrees. We need to prove each angle of the parallelogram equal to 90 degrees. Okay. So next proof. So to prove this, first you take the two triangles, triangle ADC and triangle BCD. You take these two triangles, triangle ADC I am taking. So one more triangle, it is triangle BCD. You take these two triangles, triangle ACD and triangle BCD. Okay, ABCD parallelogram means in parallelogram opposite sides are equal, right? Here we have the common base and diagonals are also equal. From side, we can say that. So what are the angles equal here? In triangle ADC, angle D. In triangle BCD, angle C are equal. Okay, now you see, first you take the two triangles, green one, pink one. In parallelogram, so we need to prove these two triangles are the congruent triangles. In congruent triangles, corresponding parts of congruent triangles are equal. Okay. Finally, we need to prove angle C is equal to angle D. Angle C is equal to angle D. Right. Already you know that in parallelogram, sum of adjacent angle is equal to 180 degrees. From that, we can prove that this angle C equal to angle D value is 90 degrees. Okay. So now you see. First, you need to prove that you select the triangle ADC. Right down. In triangle ADC, and triangle BCD. Okay. Yeah. So what are the sides are equal here? So AD is equal to BC. Why these two sides are equal? Why? Because in parallelogram, opposite sides are equal. Right on that point. In parallelogram, opposite sides are equal. Right on that point. In parallelogram, opposite sides are equal. Okay. And now you see both the triangle have a common base. What is that common base? DC. Here DC, this side is CD. So DC equal to CD. So what is that? This is common side. Common side or common base for the both the triangles. Already in the given, in parallelogram, diagonals are equal. In parallelogram, diagonals are equal. Okay, right. That next one is AC equal to BD. Can I write like this? First letter, second letter. So first and third, first and third. So AC equal to BD. Already it is given. So can I say now what type of congruence it is? What type of congruence it is? Side, side, side. So tribulus congruence. Okay, by tribulus congruence, can I say now triangle ADC is congruent with triangle BCD. So by which congruence it is?
By tribulus.
Tribulus congruence rule. By tribulus congruence rule. Triangle ADC is congruent with triangle BCD. Okay. So now what you have to do here? In congruent triangle, you see the only green color lines. Only you observe the green color lines. In green color lines, now you see this angle. What is the angle it is? What is the angle it is? Angle ADC. Or can I say angle D? Angle D. Can I say D is between it's angle ADC. In pink color triangle, you see here. So what is the angle it is? BCD. What is the angle it is? BCD. Can I write this is angle D equal to angle C? Why these two are equal? Why these two are equal? By CPCT. Corresponding parts of congruent triangles are equal. Already you know that in parallelogram, the sum of adjacent sides are equal to 180 degrees. Okay, in parallelogram, so already it is given as a parallelogram. We need to prove rectangle. Okay, so can I write angle A plus angle C plus angle D equal to 180 degrees? How it is equal to 180 degrees? No, in parallelogram, sum of adjacent angle is equal to 180 degrees. Okay, write on that point. Or adjacent angles of parallelogram. Sum of adjacent angles of parallelogram are 180 degrees. Right on. Here angle D plus angle C equal to 180 degrees. Write down. Why it is 180 degrees? Sum of adjacent angles of what? Parallelogram is 180 degrees. Okay, so write down. Already you know that angle D value is equal to angle C value. Okay, so can I say from this? Already know that angle D is equal to angle C. Okay, both you change into in the form of D or in the form of C. Then angle D plus angle D is 180. Then 2 times of angle D equal to from 1. It is 1 and pattern. So you write here 1. So this is you write here from 1. Above from 1. Angle C equal to, we know that angle D equal to what? Angle C. Just you angle C replace with angle D, right? Then angle D is how much? 180 by 2 is 180 by 2 is 90 degrees. Therefore, angle C is also equal to 90 degrees. Similarly, we can prove angle A equal to angle B equal to also 90 degrees. Therefore, we can say that ABCD is a rectangle. Okay, is it clear, everyone? Show that the diagonals of a square are equal and bisect each other at right angles. Okay, so here given that already it is a square. The diagonals of a square, you have to prove the diagonals are equal, and also you have to prove the diagonals bisect each other, and also you prove diagonals bisect at a right angle. Okay, so to prove these three things, first you write the given. So what is the given information? So that is ABCD is a square. Right. ABCD is a square. Already you know that in ABCD square means in square all sides are equal. Okay, in square all sides are equal. That is in square all sides are equal. All sides are equal. What is that all sides here? AB is equal to BC, which is equal to CD, which is equal to DL. Okay, so this is given. So now to prove, here I am writing one by one. Here we need to prove three things here. Diagonals are equal, diagonals bisect each other, and diagonals bisect each other at right angles. So first I am writing only one thing. What is that? Diagonals are equal. We need to prove diagonals are equal. The first one is diagonals are equal. Diagonals are equal. Then to prove the diagonals are equal, what are the triangles we need to select to cover the entire diagonals? So what is the diagonal we have to consider to cover the AC diagonal? We need to select the triangle what here? What is the triangle we need to select here? Triangle ACD. Okay. In the similar way to cover the diagonal BD, to cover the BD, so which triangle we need to consider here? Triangle BDC. Okay. So triangle write down here. So proof. Write down here proof. First one. Okay. So what are the triangles we need to select? Triangle ACDR we can take, or triangle ADC also you can say, no problem. Anyway you can take. So in triangle ADC I am taking, in triangle ADC and in triangle BCD. Okay. Then how do you prove these two triangles are congruent triangles? How do you prove these two triangles are congruent triangle? Already you know that. In square, all sides are equal. What are the sides equal we have? What are the sides
equal to DC?
Here AB. No. So what is the sides are there? So you have to cover AD and BC. AD is equal to BC. AD is equal to BC. Why these two are equal? Why? Because these two sides are in square. All sides are equal. AD equal to what?
BC.
BC. Why these two sides are equal? That is already it is given. Given means in square all sides are equal. Okay. Now, what is the common side we have here? Common side is DC. Both the triangles have same base. That is what? DC. So here we have the DC is equal to CD. So these two are the common side. Okay. So one more is there. What is that? In square. Already you know that. Just a minute. Just a minute. So before writing this, you write one more thing here. So what is the thing you have to write here before writing this? No, we need to prove AC equal to B. So already you know that in square all angles are equal to 90 degrees, right? So in the given information you write this one also. Here angle A equal to angle B, angle C equal to angle D, which is equal to 90 degrees. You write these things also. Okay. So you write here. Here we have the angle D is there. In between we have angle D. Here angle C is there. Oh, okay. So angle D is equal to angle C, which is equal to 90 degrees. In square, all angles are equal to 90. Okay, angle D equal to angle C equal to 90. Now here one side is there, one angle, one side. Now you see in the figure, the angle is included between the two sides or not? You check. Yes, it is there. So now you write here triangle ADC is congruent with triangle
BCD.
by
SAS congruence rule.
yes, by SAS congruence rule. These two triangles are congruent. Okay. Now you see from this congruence triangle, can I say that diagonals are equal now? AC is equal to BD. Yes or no? Can I say now? So from this we can say that AC is equal to BD. Why these two are equal?
Well, CPCT.
CPCT. So final dialog you have to write here. Therefore, diagonals of square are equal. Okay. So let us say this is a relation 1. Therefore, diagonals are equal. You write Final statement, diagonals of square are equal. Write down in the final statement, diagonals of square are equal. So now we need to prove diagonals bisect each other, right? So to prove this, write down. To prove, in the to prove right here, to prove. So we need to prove diagonals bisect each other. Bisect means AO is equal to OC and BO equal to, what is that? OD. OD or DO, anyway you can write. So that means your diagonals bisect each other. Diagonals bisect each other. Diagonals bisect each other.
Yes, sir.
Diagonals bisect each other. Then how do you prove this? Diagonals bisect each other. So for this, you have to select the two triangles. What is that?
True.
Any opposite triangles you select here. To prove this, you select this opposite triangle, triangle AOB and triangle COD.
Yes,
Okay? Triangle AOB. So select the triangle AOB and the triangle
COD.
COD. Okay?
Yes, sir.
Can you see what are the sides or angles? What are the things are equal here? To prove this, first you see that in square all sides are equal. What are the sides we have here in square? So triangle AOB, AB is there. In COD, CD is there. Okay, so then we can I write this AB equal to CD? Yes or no? AB is equal to
CD.
CD. So
Given
you have to write your sides of square are given. You can write no problem. Sides of square also you can write no problem. AB equal to CD, sides of square. And also we know that angle AOB is equal to angle COD. Why these two angles are equal? Very good. These are vertically opposite angles. Vertically opposite angles are equal. If two lines intersect like this, then the formed angles, these opposite angles we called as vertically opposite angles. The vertically opposite angles are equal. So you write here what are the vertical opposite angles we have here? Angle AOB and angle COD. COD. So this is vertically opposite angles. Completely you have to write like this. Vertically opposite angles. Okay. And to prove one more thing, so you select this is a square, right? It's a related to parallelogram, right? So this is, let us say this is angle 1 and let's say this is angle 2. And these are the two angles lies between the two parallel sides, and this is a transversal line. And what are these two angles we can call as alternate interior angles. Okay, can I say these two alternate interior angles are equal? Okay, so write down this alternate interior angles are equal. So next one, write down here angle 1 equal to angle 2, or you can write angle, you write angle 1 is equal to angle 2. Why? Because so yeah, these are the alternate. We can write like this also, angle ABO or angle ODC or something. You can write. Other simply you can write angle 1 equal to angle. You mention here 1 and 2 here also. Okay. So after mentioning, sorry, after please denote the angles here also. Otherwise, you will get wrong mark. Okay, just denote the values 1 and 2 here also. Otherwise, you don't write. You write like this. DAO, like that also you can write. D has to come in between. So you can write ABO, angle ABO, and we can write as angle CDO. Okay. So now, why these two angles are equal? You need to mention here. These two are the alternate interior angles. Alternate, you write here, alternate interior angles. Alternate interior angles. Why these two are alternate interior angles? Why? Because here AB is parallel to what? AB is parallel to CD. Which one is the transversal line? BD is the transversal line. Write down that point also. Here AB is parallel to CD. And which one is transversal line? BD is transversal line. Completely you write here. Can I say from these? So this is a side and this is angle and this is angle. So can I write A Yes. From AS, can I say these two triangles are congruent?
Yes.
Yes. Write down. From AAS, write down. Triangle AOB. Triangle AOB. Congruence with triangle COD. By which congruence rule?
Yes.
By angle side congruence rule. Okay. So from this, can I say now AO is equal to OC and BO is equal to OD? Can I say? From this, can I say AO is equal to so from this, can I say AO is equal to CO and BO is equal to DO? Why? Because these two are
CBCD.
From corresponding parts of congruent triangles are equal. So from this, can I say diagonals bisect each other? Yes or no? So therefore, write down. Therefore, let us say this relation you give 2. Therefore, you write here diagonals bisect. So diagonals bisect each other. Diagonals bisect each other. Okay. So now another one, we need to prove diagonals bisect each other at right angles. Okay. This is the next one. To prove diagonals bisect each other at right angles. Hey, listen. Any one of the angle you just prove as what is that? 90 degree. Let us say to prove angle, what is that angle we found here? Angle AOD equal to at the diagonals we need to prove 90 degrees. To prove this, what you need to select is you select the adjacent triangles. Adjacent triangles you select. Any two adjacent triangles you select. Okay, any two. But we need to prove AOD. AOD attached adjacent triangle you select. AOD attached adjacent triangle. Which one is AOD attached adjacent? This one or this one? Anyone you can take. No problem. Okay. So now you see proof. Write down the proof. Proof.
Yes, sir.
In triangle AOD. In triangle AOD and triangle what is that? AOB. Yes, AOB. Right? This is the triangle AOD. You see, this is the triangle AOD. AOD.
Yes, sir.
Okay? And another triangle is?
AOB.
This is the triangle AOD. Adjacent triangle is selected. Adjacent triangle is selected. Okay? AOD. Now you tell AD is equal to AB. How these two sides are equal? Can you tell the answer? These are the sides of square. Sides of square. In square, all sides are equal. Sides of square. Okay. One common side is there. Any common side is there here? Yes. What is the common side? AO, not DC. Now you see this is the common side between the two triangles. AO is here. AO also here. AO equal to AO. This is
Common side.
common side. Okay, common side.
Yes, sir.
And already just now we proved what is that? OD is equal to OB. OD is equal to OB. Proved above. Proved above. Just now we proved, right? So from this, now you see all sides S.
By
From
triple S.
triangle AOD is congruent with triangle AOB. By which theorem it is? By
Triple S.
SSS congruence rule. Okay. From this, can I say now angle AOD is equal to angle AOB? Yes or no? Why? Because from CPCT. Again, we need to prove angle AOD is 90 degrees. Now you see, everyone please look at here. Now what is the line it is? This is a diagonal BD. In diagonal BD, can I say this is linear pair? This is linear pair? Yes or no? This is linear pair, right? So sum of linear pair angle is equal to 180 degrees. What this means? Angle AOD. Is it visible? Now you write here. So angle AOD plus angle AOB equal to 180 degrees. Why? Because this is linear pair. Okay. Just now we proved AOD is equal to AOB. Just in the place of AOB, you replace the AOD. Okay. AOD plus AOD, which is equal to 180 degrees. So 2 times of angle AOD. Don't move. Angle 2 times of angle AOD equal to 180. Angle AOD equal to 180 by 2. So which is equal to
90 degrees.
90 degrees. So let us say this is 3. Okay. From 1 to 3. From 1, 2 and 3. Can I say diagonals of square are equal and bisect each other at right angles. Right out. Diagonals of square equal and bisect each other at right angle. Bisect each other. Directly you write the question as this. Bisect each other at right angle. Final statement you write like this, right? Note down this.